Hello, this is Mr. Stansbury. I'm going to take you through the 11G assignment. All right, so we start with number 7 here, and we've got a rectangular tank is 3 meters by 2.4 meters by 2 meters and is full of water. Water is pumped into an empty cylindrical tank of base radius 2 meters. How high up the tank will the water level rise? Okay, so let's see if we can't maybe sketch the problem here. Okay, so here's roughly what it looks like. So you've got this rectangular prism here, 3 by 2.4 by 2, and it doesn't matter which dimensions are where because it's completely full. And then what you're going to basically do is figure out how much of this water is going to, all this water is going to fit in here, and they want to know how high up the side of the tank it's going to be. So basically we need to figure out what the volume of this is, and then figure out how to make it the same volume as this to figure out what height it is. So volume for a rectangular prism is simply length times width times height. So 3 times 2.4 times 2. Okay, so let's break out our calculator for that. All right, so we've got 3 times 2.4 times 2, and that gives us 14.4. 14.4 meters cubed. So basically we just got to figure out what's going to make the same volume over here, like what height will make it so that it's exactly 14.4 meters of water. So volume for the cylinder is going to be what, pi, it's the area of the base, pi r squared times the height. Okay, so volume is going to equal pi times 2 squared times the height, but again we actually know what the volume is now, so we don't put v in there anymore. We're going to actually put in our 14.4, right? So then we can end up dividing by pi, and 2 squared is 4, so divide both sides by pi and 4, and then that will leave us with what the height's supposed to be. All right, so we got 14.4. We're going to divide that by, I'm going to do parentheses, and I'm going to do pi times 4, close my parentheses. So it'll take that 14.4 and divide it by pi times 4. Gives us 1.1459. So let's go with 1.146. And that is going to be meters. And it's just a length, so it's just plain old meters, right? Okay, let's take a look at the next. Okay, so number 8 here, we've got 12 millimeters of rain falls on the roof. All the water goes into a tank of base diameter of 4 meters. So this whole thing here is 4 meters. So that means the radius is just going to be 2 meters, right? And then there's our height. Okay, let's clean this up a little bit here. Let's get rid of the 4 meter diameter, and let's just use our 2 meters for the radius, because that's what's going to help us find the volume here. So find the volume of water which fell on the roof. So it's, if you assume that the rain falls straight down, then really it's only hitting on 10 feet wide of roof right here by 11. So for A, the volume of water which fell on the roof is going to be 10 meters by 11 meters. We also have to multiply it by the amount of water that falls on the roof. Now we've got 12 millimeters. We want to put that into meters so that we're multiplying everything by meters, right? So King Henry died unexpectedly drinking chocolate milk. We're going from millimeters back to meters, 1, 2, 3 spots to the left. So there it is there, 1, 2, 3 spots, 0.012. So times 0.012 meters. And if we multiply that out, 10 times 11 times 0.012 gives us 1.32. And that's meters cubed. Okay. Part B, how many kiloliters of water enter the tank? 1 kiloliter happens to actually equal a cubic meter, so that would be 1.32 kiloliters. Okay, and then by how much will the water level rise in the tank? So here's our we know that it's going to have 1.32 cubic meters of water in there, and we know what the base is going to be, so we just have to figure out how high up that's going to be. So for that there, we've got the volume is going to equal the area of the base, pi r squared, times the height. Okay, we know the volume is 1.32, and we know that pi is pi, and the radius is 2 squared times h. So we're going to want to divide by pi and 4, because 2 squared is 4. So we divide this by pi and 4 as well, and that should tell us what our height is. Okay, so 1.32 divided by, let's do parentheses, and we'll do pi times 4. Again, if you don't use the parentheses, you have to do divide by pi, divide by 4, otherwise it'll give you the wrong answer. And we get 0.1050, 0.1050 meters. Okay. Yep. So we could leave it as that. It's 1/10 of a meter. Or we could, let's see, I rarely ever hear of anything in decimeters, but let's go maybe to centimeters. So let's move this over 2 spots, so that would also be 10.5 centimeters as well. Either one of those would work just fine. Okay? All right, on to number 10. The design department of a fish packing company wants to change the size of their cylindrical tins. The original tin is 15 centimeters high, 7.2 centimeters in diameter. New tin is to have approximately the same volume. If the new tin is 10 centimeters in diameter, how high must it be? Okay, so just so we can kind of get an idea here, we've got here's our tin, the original one, right? So this is what we got, 7.2 centimeters across, and that's 15 centimeters tall. And now they're making it in a new tin, which is got a little bit bigger base, so it's probably not going to go quite as tall. And they want us to figure out how tall that's going to be. And again, this is now 10 centimeters from side to side. Okay, so let's figure out the total volume there, and then we'll figure out what the height has to be to have the exact same volume. All right, so volume equals pi r squared times h. So our volume is going to be pi times half of 7 is 3.5, half of 0.2 is 0.1, 3.5 and 0.1 is 3.6, times the height is 15. So we take pi times 3.6, and that should be squared. That's the pi r squared. Times 15 gives us 610.7, and that is centimeters cubed, right? So we know that this has to have the same volume, so it's going to be the same formula. Volume equals pi r squared times h. We now know that the volume is 610.7, and that has to equal pi times the radius, which is half of 10 is 5, squared times h. So we'll just want to divide by pi, and 5 squared is 25. So we divide by pi times 25, and that will tell us what the height of the can should be to have the same volume, right? So we got 610.7 divide by pi, and also divide by 25. So again, if you don't use the parentheses, you got to push both of those. Both those have to be divided by. We get 7.775. So let's call that 7.78, and this is centimeters. Should be our height. Okay. Now it does say here to give your answer to the nearest millimeter. This is in centimeters, so if we want to give it to pay attention to the directions, then we want to change this into millimeters. King Henry died unexpectedly drinking chocolate milk. To go from centimeters to millimeters, we got to move 1 to the right. So we got to move that 1 over there, and we get 77.8 millimeters is the height. That's our better answer. Okay. All right, last one, number 11. fleet of trucks all have containers with the shape as illustrated. What is to be transported? A wheat is to be transported in these containers, and its level must not exceed a mark 10 centimeters below the top of the bin, because otherwise it's going to probably all spill out. So how many truckloads of wheat will be necessary to fill a cylindrical silo of internal diameter 8 meters and height 25 meters? Okay, so that's a lot of info. There's a couple ways we can do this. I'm going to start with finding out how much volume, how much wheat we can fit inside the cylindrical silo of internal diameter 8 meters and height of 25 meters. So if we're to draw that, let's see, this here is 8, but we don't want that. We want just the radius, so that's going to be half of 8, so that would be 4 meters. And then the height here is going to end up being 25 meters. Right? So to find the volume of that thing, pi r squared times the height. So pi times 4 squared times 25. Okay, so let's try that one. We've got pi times 4 squared, or 16, times 25, and that gives us 1256.6. We'll call that. That's meters cubed. So that's the total volume that we need to transport in these trucks. Okay. Okay. So now we're going to want to figure out how much volume we can fit into this, into the truck, the back of the truck here, right? So let's do this. If we can figure out what the area of this side here is, and we multiply it by its length here, that will give us the total volume. Okay, so I'm just going to redraw this side right here over here. So here's the top, here's the sides, and then they come in here and meet in here. So that's this side right here. Okay, this top length here is 3 meters. These sides are 2. We don't know what those are, but we do know that this middle here, all the way down here, that's 3 meters. Okay, so now if we can take this thing here and we can cut it into 2 different pieces, let's cut this into a rectangle and a triangle. Okay, so if we do that, we can figure out what the area is. Now, before we figure out the area of this rectangle, remember we have to go 10 centimeters down here. So we basically really are, what we're trying to figure out is this area right here, and 10 centimeters below. Now we're talking about of meters, so 10 centimeters. King Henry died unexpectedly drinking chocolate milk. So to go from centimeters back to meters, we got to move the decimal 2 spots to the left. So this is going to have to go here, so that's 0.1 meters below. So instead of this being 2 meters, we have to subtract 0.1 meter. So let's turn that now into, so if we take 2 minus 0.1, that's, 1.9 meters. So this is 1.9 meters. And then same thing here, take away that, well, this whole thing is 3 meters. That's not going to affect us too much. So to figure out the area of the rectangle here, that's going to be 1.9 times the 3. Okay, so let's try that out here. We've got 1.9 times 3, and that gives us 5.7. So that's 5.7 square meters. And then we got to also find the area of the triangle down here, right? So the area of the triangle is going to be 1/2 the base, which is 3, times the height. And the height, if this whole thing from here to here is 3, and that from here to here is 2, that leaves this as a, is going to have a height of 1. So half of 3 times 1 is just going to give us 1.5 square. Okay, so we add these together here, and that gives us 0.2 plus 1, 5, 6, 7.2 square meters. Okay, and then to figure out the total volume of this entire truck or container here, we just got to take that area of the base and multiply it by its length. So volume of the truckload will equal 7.2 times 5. Okay, so let's figure that out. So we got 7.2 times 5, and that gives us 36. So that's going to be 36 cubic meters will be able to be carried in each truckload. Okay, so now if we've got a total volume that we need to transport of 1256.6, and each truckload can carry 36, let's figure out how many how many we're gonna need. How many truckloads? So take 1256.6 divided by 36, and then we'll see what we get. 1256.6 divided by 36, and we get 34.9. So that means can't have a 0.9 of a truckload, so we need 35 truckloads or container loads to make the entire thing happen. Okay? All right, that's all there is for 11G. So if you have any other questions, please feel free to ask in class. Thanks.